Hi everyone, and this is Module 2 Linear Algebra Unit 5 Inner Product Spaces. Here we see the examples in Euclidean inner product on R power n. If you take x vector 1, 2, 3 and y vector 4, 0, 1, what is the value of inner product x comma y equal to 1 dot 4 and 2 dot 0 plus 3 into minus 1. So 1.4 equal to 4 plus 0.2 equal to 0 minus 3 equal to 4 minus 3, we get the value is 1. Next example 2, complex inner product on C power n. For x comma y belongs to C power n, inner product x comma y equal to summation I equal to 1 to n xi yi bar. If you take the x vector 1 plus I comma 2, y vector 2 comma I. What is the inner product? X comma y equal to inner product 1 plus 1 plus I into 2 bar plus 2I bar into, you have to multiply is 1 plus I into 2 bar plus 2 into I bar. So what is the value? 1 plus 2 bar, 2 is a real number, 2 bar means again 2. So the value is 2 plus 2I. Second one, I bar means we get minus I. So minus 2I. Minus 2I. Minus 2I. So we get minus 2I. So we cancel the term. So we get 2. So therefore inner product x comma y equal to 2. Third example, inner product on function spaces. Let v equal to C of closed interval a comma b. Inner product f comma g is defined integral a to b f of x dx f of x g of x into dx. We example f of x equal to 1 and g of x equal to x on closed interval 0 comma 1. Then we substitute these values in this defined inner product f comma g. We get integral 0 to 1. F of x value is 1 and g of x value is x. So we integrate the term, we get integral 0 to 1 x into dx. So integrate this term, we get x square divided by 2 and we apply the limit, lower limit 0, upper limit 1. Substitute the limit, we get 1 by 2 minus 0, 1 by 2 minus 0. So we get the value is 1 by 2. So next definition, norm, distance, orthogonality. What is the definition of norm? Norm V equal to inner product V comma V. Distance d of u comma v equal to norm of u minus v. Orthogonality inner product u comma v equal to 0. Using this norm definition, we see the one theorem. Let V be an inner product space over F, then for all x comma y belongs to V and C belongs to F, the following statements are true. Norm Cx equal to modulus C into norm x. Norm x equal to 0 if and only if x equal to 0. Then we prove the Cauchy-Squarce inequality. Modulus inner product x comma y less than or equal to norm x into norm y. And prove triangle inequality norm x plus y less than or equal to norm x plus norm y. Proof. Subdivision A, we know that now modulus Cx equal to modulus C into modulus X. Norm Cx squared equal to inner product Cx into Cx. Norm Cx squared, we have to take the scalars in first term C, and the second slot we get C bar. So we can write C into C bar inner product x comma x. So C into C bar is nothing but modulus C squared inner product x comma x. Inner product x comma x is nothing but norm x square. So taking square root on both sides, we get norm Cx equal to modulus C into norm x. So subdivision B, we have to prove norm x equal to 0 if and only if x equal to 0. It is clear that norm x equal to 0 if and only if x equal to 0. That means if norm x equal to 0 means we can write inner product x comma x square root of inner product x comma x equal to 0. That is nothing but inner product x comma x equal to 0. Already we see the result in module 1. Inner product x comma x equal to 0 if and only if x equal to 0. Using this result, we can write x equal to 0. So next, Cauchy-Squarce inequality. If y equal to 0, then the result is true. If y not equal to 0, we have 0 less than or equal to inner product x minus cy comma x minus cy. So you have to multiply the terms and we get inner product x comma x minus c into inner product y comma x minus c bar into inner product x comma y plus norm c squared into inner product y comma y. Choose C equal to inner product x comma y by inner product y comma y. Then C, you have to find the value C into inner product y comma x, C bar into inner product x comma y, and modulus C squared into inner product y comma. So all the terms you have to find out the value. So C into inner product y comma x equal to, already we choose the value C is inner product x comma y by inner product y comma y into inner product y comma x. What is the value of inner product x comma y into inner product y comma x is nothing but modulus inner product x comma y the whole square divided by inner product y comma y. Similarly, C bar value is also, we get the modulus inner product x comma y the whole square divided by inner product y comma y. Also modulus c squared into inner product y comma y is equal to modulus inner product x comma y the whole square divided by inner product y comma y. Substitute all the values in 0 less than or equal to inner product x comma x minus c into this equation. You have to substitute this equation. You have to substitute all the values in this equations. We get 0 less than or equal to inner product x comma x minus modulus inner product x comma y the whole square divided by inner product y comma y. You have to take the LCM and simplify the terms. We get norm x squared into norm y squared greater than or equal to modulus x comma y the whole square. Taking square root on both sides, we get the result. Similarly, triangle inequality, we have to prove it. Norm x plus y the whole squared, you have to split the term inner product x plus y comma x plus y. Split the inner product terms and simplify it. Inner product x comma x is nothing but norm x square. You have to write those terms 2 into real part of inner product x comma y plus norm y square. So this is less than or equal to norm x squared plus 2 into norm x into norm y plus norm y square. So using the formula norm x plus norm y the whole square, taking square root on both sides, we get the triangle inequality result. Thank you.